Welcome to RF lecture series. In this lecture, today we'll discuss about the oscillators. An electronic oscillator is an electronic circuit that produces a periodic oscillating electronic signal, often a sine wave or the square wave. So oscillator converts the direct DC power from the power supply to an AC signal. So they are widely used in many devices. So what is the purpose of using the local oscillator? So this local, already we have seen the mixer block where we need the local oscillator to generate the high frequency. This high frequency is generated by using the cosine symbol, that is cosine of 2 pi f naught t. So here this f naught t is the high frequency. So this, you can see this oscillator is not directly connected to the any input signal or the output signal. So it is an separate block which it generates the high frequency carrier waves. What are the different types of RF oscillators? So RF oscillator is nothing but a harmonic oscillators. This is a class of circuit that is capable of producing a stable sinusoidal waveform with low phase noise. So what is a low phase noise? Is like we generate the carrier, we use the carrier block, which generates the high frequency. Whereas in ideally, there should not be any the phase noise. But in practical applications, when we go for designing the RF circuits, high transceiver circuits, then we will have the minimum amount of low phase noise. So now we'll not discuss about the topic of low phase noise because it's a very depth we'll see in a separate lecture series. Now I'll see there are different types of RF oscillator like tuned circuit oscillators, RC oscillators, crystal oscillators, and negative resistance oscillators. In this, I'll delete this to RC oscillators and crystal oscillators because it deals with the low frequency, like up to 10 gigahertz. So whereas we are going to deal with the high frequency RF signals. So let's talk about only the tuned circuit oscillator and the negative resistance oscillators. What is a tuned oscillator? The tuned oscillator uses a frequency selective or a tuned circuit in the feedback path and is generally sinusoidal. So here you can see this is the architecture of the tuned oscillator. So here we can see it is like op-amp. We use the op-amp amplifier, that is this output of this feed network is given to the input, and here always we have this in tuned oscillator, we have the positive feedback circuit. So this is a positive feedback circuit, the input will become as 0. So here the output will given as to this input. So this type of oscillator example we can see as a Colpita oscillator and a Hartley oscillator. We're not going deep into this. So if you see this in Colpita oscillator, there you can see this BJT. The output of BJT is connected to this input. Out feedback is connected again to this ground terminal. That you can refer it. Next is I'll show the negative resistance oscillator, which is one of the best example for using the in RF oscillator. One of the most popular negative RF oscillator is the negative resistance oscillator. So this negative resistance falls under the category of harmonic oscillators. Here you can see this is a very simple block of VCS and RLC oscillator. And here you can see this is a transistor which is crossly connected. So when we have the negative resistance is generated, we are giving the negative resistance. So what happens is we'll cancel this resistance. So we'll generate the negative we'll get the signal, oscillated signal, where signal is produced using this LNC circuit itself. So what we do is we are giving the negative resistance with this feedback with the feed network circuit by using the crossbar. So we cancel this each other. So what happens is we produce the positive feedback of that signal amplitude will remain as a same. So when we cancel each other from the negative resistance, we'll have the positive feedback of oscillating signal, whereas here this amplitude will become very less in this negative resistance oscillators. So now this is the voltage control oscillator. So whatever we have seen, this is local oscillator. In local oscillator, previously what we have seen is if we move this, it is depends upon the frequency of F naught. If we vary this F naught frequency, so that output also will get vary. Whereas in local oscillator, voltage control oscillator or VCO is an electronic oscillator whose oscillation frequency is controlled by an voltage input. Whereas if we don't have any input signal here, this local oscillator itself will generate, VCO itself will generate a signal. There is no one external signal is given. Here you can see this when we change this input signal, the output of the signal also will get vary. For example, this is an formula for f of t is an output. Here this f naught will become a constant, will not change anything. So whereas when we generate the vary this voltage in from the VCO, this V is for the VCO voltage. If we vary this voltage, obviously the output signal also will get vary. Here you can see this when we are there's a instantaneous changes in this amplitude of the signal. So here we on the distant instantaneous signal oscillation signal. So here you can see this oscillation of the signal is vary. So it depends upon when Vn is high, your that is oscillating voltage control oscillator signal is high, oscillating signal is high, then the output also will be in the high. So this is a vice versa mechanism. So thanks for watching. In next block, we'll discuss about the phase locked loop circuits.